Now, basically, partitions are sort of out of the experience. We have framed the problem like this, that we are asking for the cardinality of this set ABC. And is the network okay now?
Yes, it's fine now, sir.
All right. So this thing is positive, means non-negative, sorry, because you could have 0. And this is equal to n, right?
Yes, sir.
So can you identify this thing as the coefficient of x to the power n in some polynomial or something? That is the question.
Identify what, like A, 2B, and 3C? Or?
No, this number. So let's call it something.
Okay.
Let's call it Cn, right? So
Yes.
if you consider this polynomial, then, or rather, it's an infinite thing, right?
Okay. Yes, sir.
You see that, right? I've attached these numbers onto a polynomial, onto a power series, right?
Yes, sir.
So basically, can you rewrite this into some interesting polynomial, into something compact, right? For example, if I just to give an example, if I just wrote this, then you would say, yeah, this is just this. I mean, obviously under reasonable assumptions.
Yeah. Yes.
Right? Or even without assumptions, because it's a purely formal thing. But never mind. At least under assumptions. So you see, this is what I'm talking about. This is a very nice way to solve combinatorics problems. So generating functions. But anyway, that's just the word.
Okay.
So yeah.
Yes, sir.
How does it look like, right? So how do you come up with this this thing? So let us see. One way could be like this. Right, because this is adding up to 1, right? So this addition here sort of suggests a product of polynomials. Okay. So this A, which doesn't have any coefficient, this can correspond to this infinite formal expression.
Right. Okay.
So, right, because you see, so if you collect x to the A from here, that will be this A. Okay. And similarly, you see for the next one, because here you see every number here has weight 2, right? So I will instead do this. You understand? And
right.
similarly,
and the third one will be x cubed.
Right. Now you should think and try to see if the coefficient of x to the power n here has anything to do with the Cn there.
Yes, it's exactly. Oh, 1 second. Yes, sir. It's exactly the number of ways to write n as a plus 2b plus 3c. Because of the way you've chosen the coefficients.
Correct. So this is it, right? So this expression is this. So now you can say, what is x? Can I put x equal to 1, 2, and so on? No. At the moment, x is a variable. Okay. X is simply x is just a, so I should not even say a variable. I should say x is a symbol. Right. X is a symbol.
Right.
Okay. And x square is also a symbol. X cube is also a symbol, and everything here is symbol. And these symbols are manipulated by usual rules of addition and multiplication.
Okay.
Okay, that is all.
Right.
Right? The multiplication will be as you multiply polynomials, but we are just multiplying symbols. It doesn't means it should not. You should take inspiration. I mean, you should take motivation and inspiration from what happens to usual numbers, usual differentiation. But you can try to apply it here and see if it works. But you have to prove it separately because these are just symbols. Okay.
Okay.
Yeah, like if you differentiate both sides and something goes wrong, then you cannot say why it's going wrong. Because these are not numbers, these are symbols. Means you have not defined a calculus on it and shown that those rules of derivatives will apply here and so on. Okay. So this is it. And now the question is that can I simplify this? Can you simplify this? Obviously the right answer.
Yes, sir. First one will be 1 over 1 minus x.
Okay. So now you have to explain. why is this thing equal to 1 over? So let's go on a new board and try it, because this is, once you understand this, then you can just read these things very easily. So
Yes.
I want to go to a new board. Yeah. So let us see. So let me first make a definition so that we don't have to fumble this thing. So I will say that I am defining this set. So you look at complex numbers, or you can say put anything there, R also. And I'm defining this,
Okay, yes.
right? This is my set. What are the elements of this set? Elements of this set are formal symbols like this.
Right.
N equal to 1 to infinity. And Cn is in C for all.
Okay.
And multiplication and addition is defined as you expect it. Okay.
As usual. Yes.
Yeah, as usual. Correct. So this has an addition. This has a multiplication.
Right. Yes.
I am
sir.
not saying x is a number, so you cannot substitute x equal to something else. Okay. This is called ring. This is a ring because you have studied